Hi folks, here we have my Raspberry Pi IO card breakout box. The Pi and all the IOs are brought out to the front of the box. I'll turn it over and we'll have a look at the other side. Okay, this is the working side of the board. As you can see, we've got the Raspberry Pi 3 sitting here at the base of the mounting bracket. We also have a homebrew IO card, has 16 open collector outputs. 8 digital inputs, can run from 5 to 30 volts. The outputs are operated from 9 to 30 volts. We also have 5.1 volt power supply sitting here, just using an LM chip to do the job. Also adjustable, so if we had the voltage problems with the voltage resistor dividers, we can adjust it in, and also choke so it works as a buck converter. For those that don't understand it, have a look at buck converters and you'll find out all about it. And here we have a standard Samsung 21-inch monitor with a plug pack power supply. The power supply has been modified slightly. As you can see over here, the plug's been removed, the original plug and cable have been cut. It's been set up so it can plug into the box that we were just looking at, and the power supply comes back out again. It can also supply the power for the Arduino, the Raspberry Pi. I didn't mention the Arduino earlier, but we'll go into that shortly. The Raspberry Pi and the output module. This is a rear view of the monitor with the on the rear of it. As you can see, the power supply cable plugs into the box and then comes back out again into the monitor. There's also a HDMI cable running from the Raspberry Pi in the box across to the monitor. This makes a very nice, neat, compact unit. And if we have a look around on the side of it, we can see now that we can actually get at all of the I/O ports and the USB ports, and also the LAN port, and at the base where the HDMI cable plugs into it, we can also get at the audio plug if we require it. The green plug in the middle of the board allows you to put an external power supply directly into it. DC input anywhere from 9 volts through to 30 volts, and it will power the monitor and the IO card and the Raspberry Pi internally. As you can see, the Raspberry Pi is just firing up, booting up, loading up. Then we have the desktop running Raspbian. There are quite a number of extra apps that have loaded onto the machine. One of them that I use quite a lot is Canvas. Beautiful little OOP IDE, programming in the basic language. All absolutely suited to this. There's also a number of other features there that use it, allow us to talk to a Arduino as well. So the next thing I'll do is connect up the Arduino and we'll have a look at that on hanging off it. I've now connected the Arduino Uno onto the rear of the unit. You can see at the top corner there, we can probably have a closer look at that and see that we have coming in and out of the Raspberry Pi, we have our 16 open collector outputs, and we also have our 5 to 30 volt DC inputs. All of these are digital. The idea of being able to use the Raspberry Pi rather than to try and the Uno with the Raspberry Pi is to try and be able to set up analog to digital converters, which is quite difficult on the Raspberry Pi, and also pulse width modulators makes it much easier to do if you use the Uno with it as well. That's why the Uno is on there. The other thing that's fascinating about it is that we are able to program the Uno directly from the Raspberry Pi. I now have the Raspberry Pi all booted up with the Uno up on top, so you can see that. See the LEDs light on it. So now we'll go ahead and see if we can make some communications and load some programs down onto it. Now I'll load up a little editor that was written in Canvas. It also uses C script, so we just open the file. We'll go for blinks at the moment and we'll open it up. We'll now, as you can see, basically C script. We'll just go ahead and make or compile the program. There it goes, using AVR Dude We also use AVRDude to download it to it. Now, if you have a look up at the top, you can see that the UNO has the onboard LED flashing on and off once every second. So you have a look down in the code here, you can see that we've set it at 1000, so it's 1 second on, 1 second off. That works fine for us. I'm now going to open up the file for serial communications. So we'll go over here and open the file up, serial, open it up. As you see, it's just a little C script again. We do a compile, download, all done. Now we'll close the file. Okay, again written in Gambas, a little comms program, allows us to communicate with the UNO from the Pi. That's I usually set all my baud rates at 19,200, find it's just about perfect, particularly for some little 433 megs modems that I use, wireless modems. So what we'll do is we'll put in here H for high, and we will open the port. We'll see if we can send that, and there we go. The LED on the board on the UNO has gone on. Also tells us LED is on. If we then put an L in there and send that, we now go low and it says the LED is off. That proves that our communications is working correctly between the UNO and the Pi. It makes for a very nice little setup. Allows you to be able to use pulse width modulators, and particularly the analog to digitals that aren't so easy to do on the Raspberry Pi, and keeps all the I/O pins available on the Pi for general purpose input output. You can see we've got Bluefish editor for doing the other bits and pieces. It's also set up that we can some example codes there of turning I/O on and off on the Raspberry Pi using a web editor or logging in remotely over the internet and being able to run a little interface program so that you can do all that. And there is just reams and reams of stuff on there. It's also set up with an Apache server on it, so you can log into the machine remotely. Also the Wi-Fi is set up and running, as you can see up the top here. It's actually connected to my Wi-Fi network. Everything's up and running on it, and it's a lot of fun. One of the things I didn't mention was that I don't boot and run off the SD card. I use any old little SD card, do the primary initial setup on it, and then boot off a USB memory stick. I find it much faster, much better to use, and gives me a lot more flexibility. I can change operating systems very quickly, or different flavours of the desktop. It makes it very simple. Also, I've just put up my contact details, so if anyone wishes to contact me, you can do so by email, mike.crean@y7mail.com. Okay, thanks very much for viewing. Hope to catch you soon. Bye.